Welcome back to your fourth and final day of the endocrine system. So today's aim is, how do feedback mechanisms work? But before we get into that, you guys have got a do not question. So as always, pause this video, answer that question on your own, and come back when you're ready to review it. All right, number one, select the endocrine gland chosen from the list below that is best described by the statement shown. The islets of Langerhans that produce insulin are structures in this gland. Now, you may have taken one look at this question and been like, I don't know what an islet of Langerhans is. I give up. It's done. I'm a lost cause. But I'm here to tell you, you don't actually need to know what an islet of Langerhans is in order to answer this question. You just need to recognize one word. And that one word is insulin. So what is insulin and where do we find it? Insulin is a hormone that is produced by the pancreas. So your answer here is A. All right. Now, on your paper, as well as on Google Classroom, as well as beneath this video, I have linked another video that I actually want you guys to watch first thing today. And that video is going to outline the answers to questions 1 through 7 that you need to know about the endocrine system. Now, I will warn you, this video is a little cheesy, but I think it's a fun cheesy, and I think you're going to enjoy it. And you may not want to admit that you enjoy it, but you will. So go ahead and pause this video, go watch the other video that I have linked, answer these questions, and come back to me when you are ready to review them. Now, if you're still here, I'm assuming you have already watched the video, okay? And if you haven't, pause me, go watch that, and then come back. Okay, now, if you're really still here, I'm assuming you have watched that video, and you're like, please, Ms. Collins, just go over the answers. All right, let's get to it. Number one, how are hormones different? So we know that hormones have different jobs, right? They're going to be in charge of different things, but how do they know where to go and what to do? Well, if you think back to Unit 2 or Unit 3, we talked about enzymes. And we talked about something called the lock and key theory, right? Which talked about, I'm saying talked about a lot, which mentioned that enzymes are going to be specific to a receptor based on their shape. Hormones work the exact same way. So hormones have different shapes and only match with and communicate with specific target cells. If they don't have the same shape, they will not connect. They have to have the same shape in order for that hormone to match up with the correct receptor. Okay. Number two, what is the function of the master gland, also known as the pituitary gland? So this was that tiny little annoying gland at the beginning of the video, and he was on an intercom shouting orders to all of the different glands. That is because the job of the pituitary gland is to communicate with other endocrine glands and regulate their action. He is in charge of making sure every other gland does what they're supposed to do. But number three, what does the pituitary gland produce and why is it so important? We also need to know that the pituitary gland produces growth hormones. This is what's responsible for making you grow. It dictates how tall and how fast you grow. All right, number four, what is metabolism and how does our body regulate it? Metabolism is how fast your body uses calories from the food that you eat in order to undergo life functions. And this is regulated by the thyroid. That was that organ that we saw wearing a little bow tie. The thyroid regulates how fast or how slow your metabolism is. Number five, adrenal glands are responsible for producing the hormone known as adrenaline. We also call this hormone epinephrine. And this hormone is only used in cases of emergency. Remember when the two characters of that video rolled up to the adrenal glands, they were sleeping, right? That hormone adrenaline is not released until your body thinks you are in danger. So every other moment of the day, your adrenal glands are just chilling. They're not really doing anything until they sense danger, and that's when they kick into gear. All right, number six, what does the pancreas do? Hopefully we know this by now. The pancreas releases insulin when blood glucose is too high and releases glucagon when blood glucose is too low. So again, insulin is going to decrease blood sugar and glucagon is going to increase it. And finally, number seven, why are the reproductive glands important? So you either have ovaries or testes. The ovaries produce estrogen, which is known as the female sex hormone, and the testes produce testosterone, and this is known as the male sex hormone. Okay. Now, I've got a little video for you that shows kind of how this works. So earlier I mentioned that hormones work similar to enzymes, right? They're going to match up with a specific receptor based on their shape. And this is kind of what that looks like. So if you look here, this circle right here represents an endocrine gland. And you can see that these little shapes are being released or secreted. That is because endocrine glands secrete hormones. Char, it's okay. Endocrine glands secrete hormones, okay? And those hormones are going to be, again, specific for a receptor. So in this case, we've got two different receptors. We see one receptor is kind of round shaped and one receptor is square shaped. So looking at our hormones, which receptor do you think they're going to bind to? Okay, we actually see in this picture, they are binding to receptor C, which means that receptor A is what we call the non-target cell. This hormone is not meant for that cell. It's not meant for that receptor. They don't have the same shape. They are not going to match up. That also means that letter B, which I think oh, there it is. I was going to say, I think I covered it up. Letter B is our receptor. Okay, that is the structure that's found on the surface of the cell where the hormones actually bind. And so because of that, we call C our target cell. This is the cell that the hormone is geared towards. That's what it wants to match up with in order to cause whatever reaction it is known for. So if you look below, I've got a video of what happens when insulin binds to the correct receptor. We see that insulin, this little yellow molecule right here, is binding to this green receptor on the cell. And the second that it does, this pathway opens up that allows glucose to flow into the cell and get out of the bloodstream. So again, this is how insulin works in order to decrease the amount of sugar in your bloodstream. So it's going to lower your blood sugar levels. Okay. The last thing we'll do today is read a short passage about what exactly is dynamic equilibrium. Okay, yesterday I told you that the act of insulin and glucagon regulating blood sugar is known as negative feedback, but then I kind of left you on a what is it called, like a cliffhanger there. I didn't tell you what that meant. So today we are finally learning what that means. So let's get to it. Dynamic equilibrium describes the constant small corrections that normally keep the internal environment within the limits needed for survival. This is also known as homeostasis. Organisms, including humans, have mechanisms that deal with interferences and restore the normal state. A feedback mechanism involves a cycle in which the output of a system feeds back to either modify or reinforce the action taken by the system. A variety of feedback mechanisms have evolved to help organisms detect and respond to stimuli, changes in the environment. Okay, so there are two different types of feedback. Remember, I've equated this to what happens whenever you turn in a lab report. And I write on your lab report feedback. I either tell you what you're doing well or what you need to do better or do differently. And the same thing happens in our body. So there are two types of feedback. I underlined the phrase either modify or reinforce the action taken by the system. When we see this word modify, it means change. And this word reinforce means keep doing it. Again, the same thing happens on your lab reports that happens here. I'm either going to tell you to change something or keep doing what you're doing. Keep up the good work. Okay, I'm actually going to change that. Keep up the good work. Okay, so what's the difference between positive and negative feedback? This doesn't mean that one is good and one is bad. It just means they're working differently. Whenever we see the phrase positive feedback, in positive feedback systems, a change prompts a response, which leads to a greater change and greater response. So positive feedback works to reinforce that action. Keep up the good work. Keep doing what you're doing. And that's an example of this is breast milk. So when a baby is going to suckle on his mother's breast, the mom's body will signal for more milk production. So it sees that, okay, this is working, we need more milk, and it's going to keep producing milk. So positive feedback is an example of reinforcing those changes. This is the body's way of saying, keep up the good work. Keep doing that. Okay? But negative feedback is a little bit different. So in negative feedback systems, a change prompts a response, which leads to a signaling of stop or reduction in response. This is an example of modification or change. Okay, so an example of this is body temperature. We also talked about the example of insulin and glucagon as an example of negative feedback. So with this, with body temperature, when you get too hot, you're going to begin to sweat. And when you get too cold, you're going to get goosebumps. Negative feedback is the body's way of saying, hey, stop doing that and do this instead. Okay, so I'm gonna see. I'm running out of space here. Okay, stop doing this. I really didn't plan this out well. Let's see. Do this instead. Okay. I kind of had to cram that in the margins, but hopefully you're able to see that. With negative feedback, the body is basically saying, hey, stop doing that. We need to stop. We need to turn it around and do something else. So, for example, when you get too hot, you're going to sweat. That is going to lower your body temperature. When you get too cold, you're going to start shivering. That's going to increase your body temperature. So, both of these feedback mechanisms are working to maintain homeostasis. They just work in different ways. Again, positive feedback is telling your body, keep doing that. That's great. Keep it up. Negative feedback is telling your body to stop and do something else, do something different. Okay. That is all I've got for you guys today. So please pause or end this video. I'm done. Answer your exit ticket questions and have a wonderful day. I will see you tomorrow or Tuesday, whenever you're watching this. Have a good weekend.